You know about derivatives, you've learned them well. If you never learned derivatives, get ready for an L, cause now it's time to add to the equation. Say hello to antidifferentiation.
This process goes by many names, well, really just two, and the other's integration. It's the process of finding an integral and then adding a constant, and you're ready to roll.
Integration and derivatives go hand in hand. They're the inverse of each other. You understand? We know that a derivative is f prime of x, while the integral is labeled big F of x.
Derivatives, we know, are power reducing. Well, using just a bit of clever deducing, we can reason that an integral's power is higher, just like a college student at a bonfire.
Finding an integral is really a breeze. With this one simple step, you can do it with ease. Take the power of the term and raise it by 1. Divide by the new power, and now you're done. Now wait just a minute, there's a problem there. That tells you what it looks like, but doesn't say where. Fixing this problem is easy as can be. Just add a constant and label it C.
There's a vital theorem called the FTC. That's the Fundamental Theorem of Calculus. With a definite integral from A to B, just find big F of A and subtract big F of B.
But what's the use? What's the purpose? If you need to find the area under a curve, you can serve up the answer with an integral. This application is critical.
It's the reason we use integration so often. Get this through your head and you'll be a boss in
calculus.
Especially in area. This stuff is important. It's not meant to scare ya.
Remember, in derivatives you had to know the trig derivatives wherever you'd go. Well, that's the same for integration. Memorize these. No further explanation.
Now, sometimes the power rule doesn't work out, so you need another method. We're talking about U-substitutions. They're kind of fun. Take a seat, and we'll show you how it's done.
You remember from derivatives the old chain rule. Well, this is like that, but twice as cool. You need to find the inside expression and say that it's equal to U, and take it away.
Let's take the example of sine 2x. The u for this equation is just 2x, so we say that its derivative is 2dx, and you got all that, but then what's next?
Write out the integral in terms of u and du, but you'll need to use a coefficient. You'll see the 2 from du has gone missing, so take the reciprocal and put it on the outside.
Now you have something pretty weird looking. U instead of x? What kind of crap are we cooking? Just integrate as if you have x in there, and plug 2x in for u when you're done.
This is all you need to do for most situations, but sometimes you'll get a special occasion with the definite integral. Take a and b and plug them in to the u equation.
Now let's say you got a particle traveling through space and you know its speed, but you want to know its place. Well, that's not hard with this new information. Take the velocity function and use integration.
The definite integral from time a to time b will tell you the place where the particle be. Be sure to account for the initial position. Add it to your answer. Don't let it go missing.
There's another theorem that you need to know. This one's easier than the other one. It states that the derivative of an integral is the original function. Isn't that cool?
Well, that's the end of this learning session. We hope you got a lot out of this lesson. And now that you know about integration, you're truly a part of the Calculus Nation.
Into the distance. Oh yes, zoom in. What a function.